Oh, well, hello. So this is another very short episode of Fun with Physics. Today I want to just really quickly go through the notes that we covered in class specific to distance versus time graphs, and just a tiny bit there, and then a tiny bit on velocity versus time graphs. I already wrote it on the board. This is just big picture stuff. We've already been talking for a while about distance versus time graphs, and so, of course, we're thinking here distance versus time graphs. And the thing that we want to make sure to note is that the slope on a distance versus time graph, so we could draw that like this if we think about that, the slope, which would be equal to rise over run, which is this. That would be rise, and then run would be here. The slope is equal to rise over run, which is equal to distance or displacement over time. This equation should look familiar. That's actually equal to velocity, and it can be a positive or a negative. This would be a positive slope, so it would be a positive velocity, meaning it's moving in the positive direction. If you had a negative slope, maybe it was coming down like this. Here you would have a negative value for displacement because it's moving in the negative direction, and so you would end up with a negative velocity. But the slope of a distance versus time graph tells you velocity. Then if we completely change it up, change graphs, we go down here and we think about a velocity versus time graph. Get a little bigger. Velocity versus time graph. Similar graph, slightly different concept. We can think about it the same way, and if we make squeaky. The slope on a velocity versus time graph, once again, we think about rise versus run. Here, the rise would be the change in velocity. Could be a positive or a negative. And then the run is the same thing with time. And so this equation should look familiar as well. Change in velocity over time equals acceleration. Again, it can be a positive or a negative. It can be a positive or a negative. So the slope of these two different graphs can be velocity or acceleration depending on, is it velocity here or is it distance, position there. And then the one final thing that we want to make sure to review, discuss, is the area. The area under a velocity versus time graph equals displacement. What would that look like? So I think if we would show that, if this represents something that's happening, time versus velocity, to find that area, you would consider all of this space here, or this area. And if we made up some numbers, if we said you started at 0 time, you went to 10 seconds, and you started at zero, a velocity of 0 meters per second, and you ended up with a value of 40 meters per second after 10 seconds. The area of this would be, let's see, we got room right here. Area would equal 1/2 base times height, which would equal 1/2 20, 1/2 40 times 10, which would equal 200. What that would tell you is that 200, which would be the area of this, would tell you that the displacement would be 200 meters. And so there's times when it would be valuable to find the area under that. It would be a way of finding displacement. Thank you for your attention. I wish you the best of days.